back in sections 4.2 and 4.3, when we were studying Gauss-Jordan elimination, you heard me throw out this term identity matrix. If you recall, I told you that when you were doing Gauss-Jordan elimination, your goal, so say if you have a system of 3 equations and 3 variables, your goal was to transform your augmented matrix into this. Okay, so just write it down. And I refer to the left side of the vertical bar, this part that I'm highlighting right here, okay, as the identity matrix, okay? So basically, the identity matrix is a square matrix, okay? It has to be a square matrix, has to have the same number of rows as columns, that's what square means. It's a square matrix with ones on the principal diagonal and zeros everywhere else, okay? And that is stated right here, okay? So that's why I was always referring to that left-hand side of the goal as the identity matrix, okay? Remember, if we had a system of 2 equations and 2 variables, okay, the smaller system, the goal was still the same. There was still the identity matrix on the left side, okay, because over here, it's still a square matrix, okay, 2 rows and 2 columns if you're just looking at those 4 numbers that I have highlighted, okay, ones on the principal diagonal, zeros everywhere else, okay? So what you should be seeing here is that identity matrices come in different sizes, okay? A matrix is considered an identity matrix as long as it's square and it has ones on the principal diagonal and zeros everywhere else. Okay, so the identity will play a role in the last couple of sections of this chapter, okay? So just wanted to make sure we're on the same page about what identity matrix means, okay? Let's go ahead and look at example 3, okay? Before we do that, well, never mind. Let's just jump to example 3. It says state each of the following identity matrices, okay? So then you see I2, I3, I4, and then there's room for you to write that matrix down, okay? So remember, I've talked to you before about how we name matrices. We always name matrices with capital letters. So like in the last example, when we were doing transpose, you had the matrix A and you had the matrix B. A matrix is always named with a capital letter. If you see a capital I as the name of your matrix, that is reserved for the identity matrix. Okay, so you don't want to call some random matrix the I matrix. Okay, capital I is reserved for the identity matrix. Okay, and like I said, they come in different sizes. So when you see I2, the I indicates that you're dealing with an identity matrix. 2 is telling you the dimensions. It has to be a square matrix with 2 rows and 2 columns. Okay, so it would be a 2 by 2 matrix is what this is saying, okay? So you would have ones on the principal diagonal and then zeros everywhere else, okay? So that's I2, okay? The identity matrix size 2 by 2, okay? When you see I3, okay? I means identity matrix, okay? The 3 indicates that it's going to be a 3 by 3, okay? And then you would just write that down, okay? So it's going to be a slightly different or slightly bigger identity matrix. Okay, you're going to have ones on the main diagonal. Okay, so you would have 3 of them because it's a 3 by 3. Okay, and then you would have zeros above and below everywhere else. Okay, so it would look like this. Okay, lastly, I'll do I4, but you could go up as large as you wanted to. I mean, you could do I of 100. Okay, but who wants to do that? Okay. So I is indicating the identity matrix. Okay, the 4 is telling you it's got to be a 4 by 4, has to be a square matrix, or it's not identity. Okay, so you would draw 4 ones. Okay, that's your principal diagonal, and then you just zero out the other positions, and that is all you have to do. Okay, all right.